Greetings, fellow mathematicians. Let's investigate statistics and probability. Statistics and probability is, of course, chance and data. In the first 3 years of school, children will begin to investigate chance language. Children don't come to school with this language naturally, so it needs to be explicitly taught. They will begin to investigate picture graphs and they will begin to create picture graphs with the understanding that each picture needs to be the same size and they need to be put in rows with no gaps and overlaps so that they can tell without counting which category has the most, which category has the least. That's using chance language to interpret picture graphs. They'll begin to collect data using tally marks. They'll record their data in lists and in tables, and they will then create picture graphs. They'll have a look at all these different representations of the same data to determine their usefulness. So if we wanted to count something, tally marks or the list or table might be the best way to represent the data. If we want to be able to tell the most or the least, then the picture graph will be a more appropriate way to present the data. Years 3 to 6, children begin to investigate column graphs and they construct column graphs, they interpret column graphs, and they explain and ask questions about column graphs using the language of chance. Now they can use technology to create column graphs with Excel type spreadsheet programs. They will then conduct chance experiments. When they conduct the chance experiment, they will predict outcomes. They will use the outcomes from their first experiment to further predict outcomes. And then they will be explaining the variation in their results and the variation in what they expected to what actually happened. This is a really important concept that children will need to develop, that they need data to be able to predict chance. They will then begin to investigate two-way tables and graphs with one-to-many correspondence. They will start to order chance, and they will also start to explain when the chance of one event occurring affects the chance of another event occurring. So if I have a die, for example, and I roll a 6, that means that I couldn't possibly have rolled a 1, 2, 3, 4 or 5. But if I have 2 dice and I roll a 6 on this die, it won't affect the chance of rolling a 6 on this die. They're also going to compare and interpret column graphs, line graphs, dot plots and tables, and again explain the usefulness of each. They're going to start to display and explain probabilities using fractions, understanding that the total is going to equal 1. They will conduct chance experiments and they will start to list frequencies of outcomes. They will use the frequencies of outcomes to create their own game of chance, and they can create their game of chance to be fair or to be unfair. They will also investigate misleading data representations which can be created by changing the scale on the vertical axis.